Good morning everyone. Welcome back to the course Engineering Chemistry. Myself Dr. Harika Patnala, Assistant Professor, Department of Chemistry, MLR Institute of Technology, Hyderabad. In the previous class, we have discussed about a battery chemistry. What is meant by a cell and a battery, differences between a cell and a battery, and the components of a cell or a battery, such as anode, cathode and electrolyte. In today's class, we are going to discuss about the characteristics of a good battery. What are the characteristics should be satisfied by a battery? Nowadays, we are using many portable devices, portable gadgets. So, we are relaying a portable gadget, and these are the following criteria which should be satisfied by a battery. The first criteria was a battery should be reasonably light and compact. Some batteries such as lithium batteries have a high energy density and can offer high capacity in a compact size. In portable devices, nothing but the size of the device is very small. If the size of the device is very small, so the size of the device completely relies on size of the battery. If the battery was very small, therefore the size of the device should be small. If the device was very light in weight, then the battery also was light in weight. If the device was light in weight, is because of light in weight of battery. So, today's example was lithium ion battery. When compared with the previous batteries such as lead acid battery, nickel cadmium battery, nickel metal hydride battery and lithium ion battery. When comparing all these batteries, lithium ion battery is smaller in size and lightweight which was in compact, which was enclosed, so there is no leakage of aqueous electrolytes. In lithium ion battery, we are not going to use any aqueous electrolytes. In lithium ion battery, we are using non-aqueous electrolytes such as organic solvents. The next criteria should be satisfied by a good battery is capacity. It is a charge in ampere hours that can be drawn from a fully charged cell. It is nothing but the amount of discharge was noticed in an hour from the fully charged cell. The units are ampere hours. The next characteristic was energy density. It is the total amount of energy per unit weight of a battery is stored. It is nothing but amount of energy stored in 1 kg of a battery. It is nothing but ampere hour kg per kg. The next characteristic was calendar life. Battery should have a long life when not in use. It should have low self-discharge rate. What is meant by self-discharge rate? It is the measure how quickly. It is the measure how quickly the cell energy is discharged due to unnecessary chemical reactions. Self-discharge rate is nothing but it is a measure how quickly the cell, its energy is discharged due to the unnecessary chemical reactions. If it is low self-discharge rate, therefore the life of the battery is long life. Let us move to the next characteristic. How long a battery will last? It depends on the number of discharge and charging cycles. So, a battery is having 2000 cycles of discharging and charging is nothing but the battery will last for 5.5 years. It's a very good battery. So, if it is having 5.5 years of long last, therefore the battery is said to be good. But the number of cycles of discharging and charging depends upon the chemicals of the battery. What are the chemicals we have chosen? Which type of chemicals? What are the reactants we have taken in the battery? And also how fast the rate of charging and discharging. The rate of charging and discharging. If the battery was very fastly charging, therefore it leads to unnecessary chemical reactions. Unnecessary chemical reactions have been taken place. If there is an unnecessary chemical reactions, it leads to inactive components. So the components are changed to inactive components. Therefore, the life of the battery was lost, is reduced. How long a battery will last is nothing but it depends upon the number of discharge and charging cycles, which also depends upon the chemical components and rate of charging and discharging. So we have to prefer a battery which is having slow charging and discharging rates. Let us move to the next characteristic is state of a health of a battery. The capacity when measured at any time is called state of health of a battery. I have checked a battery state at 3 months, 4 months, at 5 months and 6 months. And each and every month I have checked the capacity of each and every battery. It indicates the state of the health of a battery. If there is due to the fast charging or fast discharging, so due to the unnecessary chemical reactions, the internal parts of the battery may be corroded. If the battery was not corroded, if the internal parts of the battery was not corroded, therefore the health of the battery is very good. So the internal parts of the battery should not be corroded or converted into inactive forms. A good battery in which the internal part should not be corroded. Let us move to the next characteristic is depth of discharge. Battery charging and discharging up to a certain range is called depth of discharge. So all these are the 7 characteristics should be satisfied by a battery. Let us move to the next topic is called classification of batteries. Batteries are classified as primary batteries, secondary batteries and reserve batteries. Let us take the first battery is primary battery. In primary batteries, chemical energy stored in the battery is converted to the electrical energy spontaneously as long as the active materials are present. If a battery is having an active material A, it converted to the B with the release of some energy. Is nothing but is the conversion of chemical energy to electrical energy. The reverse reaction is not possible in the primary batteries. These are the batteries. Chemical energy stored in the battery is converted to the electrical energy spontaneously as long as the active metals are present. If there is active material A, it is going to be discharged, releases energy and gets converted to B during the discharging process. There is no reverse reaction is possible. There is no reverse reaction. In other words, the battery in which irreversible cell reaction taken place are called primary batteries. The batteries, there is no possibility of reverse reaction. So these batteries cannot be recharged. Once it was utilized, once it was dead, it no more we can use this battery. Example, dry battery or Lackland cell we call, or lithium manganese dioxide battery. A primary battery which is an irreversible battery and cannot be recharged, which is also having a galvanic cell. Secondary battery. Secondary cells are the batteries in which reversible reaction taken place, in which a reversible reaction is possible. If A gives B plus energy, again B plus energy gives A. The reverse reaction is possible in secondary batteries, which are charging is possible. These batteries can be recharged by passing electric current. Redox reaction is reversed during the recharging. During discharging, redox reaction has been taken place. During charging also redox reaction has been taken place. The forward reaction is discharging here. If you notice, the forward reaction is discharging. The backward reaction is charging. This battery can be recharged by passing electric current. Redox reaction is reversed during recharging. Electric energy is stored in the form of chemical energy in these batteries and used when needed. Electric energy is stored in the form of chemical energy in these batteries and can be used when needed. More number of times of charging and discharging is possible. Charging and discharging cycles are possible in these batteries. In primary batteries, large number of cycles of charging and discharging is not possible. Once the battery was discharged, it is no more use. It was dead. In secondary batteries, there is a possibility of charging and discharging. Examples are lead acid battery, nickel cadmium battery, nickel metal hydride battery and lithium ion battery. If we see the differences between primary batteries and secondary batteries, primary cell acts only as galvanic cell. What is meant by galvanic cell? A cell in which the chemical energy is converted to electrical energy is called galvanic cell. The reverse reaction is not possible in primary cells, whereas secondary cells can act as both galvanic cell and electrolytic cell. What is meant by galvanic cell? A cell in which chemical energy is converted to electrical energy. In electrolytic cell in which electrical energy is converted to chemical energy. In galvanic cell, chemical energy to electrical energy. It is nothing but discharging. In electrolytic cell, there is a conversion of electrical energy to chemical energy is nothing but during charging. During discharging, it acts as galvanic cell. Yes, during discharging, it acts as a galvanic cell. And during charging, it acts as electrolytic cell. Yes, it acts as an electrolytic cell. So, the reversible reactions is possible in secondary batteries where it is not possible in primary batteries. Let us move to the next classification of the battery. The third one is reserve battery. In this battery, one of the key component, if there is a battery of anode, cathode and electrolyte, at least any one of these components should be separated from the battery and incorporated into the battery when required. In reserve batteries, one of the key component is separated and stored separately and it is incorporated into the battery when required. When long storage is required, reserve batteries are often used. There is a left self-discharge also. Because of the reserve batteries, if one of the key component is separated, therefore slow self-discharge, reducing self-discharge. Reducing self-discharge. Because one of the key component is removed, so there is no unnecessary chemical reactions has been taken place. So there is a reducing the self-discharge rate, so the life of the battery has been increased. Reserve batteries have effectively eliminated the possibility of the self-discharge and minimize the chemical deterioration. So, if there is an unnecessary chemical reactions, there may be corrosion within the battery and therefore there is a self-discharge. Because of by the removal of one of the key component, the reserve battery's life has been increased because there is no unnecessary chemical reactions. and there is no self-discharge rate. Most of the reserve batteries are used only once and then discarded. When we require high power, high energy output, when we require for a short period of time, we prefer reserve batteries. We are going to utilize once and then discarded these batteries. These batteries are used primarily to deliver high power for relatively short period of time after activation in such applications as radio sonars, fuses, missiles, torpedoes, nuclear weapons and other weapon systems. So all these nuclear weapons and weapon systems are powered by using with the help of the reserve batteries. Let us see the various types of reserve batteries. The reserve batteries can be classified by the type of activating medium or mechanism that is involved in the activation. The first one is water activated batteries. Activation by fresh or sea water. A battery in which the key component is sea water or fresh water. A battery can be activated and produces energy by adding the sea water. Until you add the sea water, the battery does not start working. Example is magnesium silver chloride battery, in which we are using the sea water as the key component. They are activated by adding the sea water. These batteries have high reliability and long shelf life. See, if we add the sea water, then only it activated. Unless sea water we have added, it is having long shelf life. There is no unnecessary chemical reactions, no corrosion. Hence, these find applications in missiles and submarines. So, magnesium silver chloride battery was used in missiles and submarines. Let us move to the next reserve battery was gas activated batteries. Activation by introducing a gas into the cell. The gas can be either the active cathode material or the part of an electrolyte. So, in this battery, air or any other gas or oxygen are used as gas activated batteries, which is the key component of the battery. Let us take an example of zinc air battery. In zinc air battery, zinc is anode. The oxygen present in the air acts as a cathode. Zinc air battery where the cell is sealed until use. When we required, so the seal was opened and we can admit the air into it and the cell was activated when it is required. Zinc air battery where the cell is sealed until use, the seal is removed to admit air and activate the cell when it is required. So, we can avoid unnecessary chemical reactions and we can get the high energy output. Let us move to the next classification of a reserve battery, electrolyte activated batteries. Activation by the complete electrolyte or with the electrolyte of a solvent. These batteries are activated by introducing the electrolyte or with the electrolyte solvent. And let us move to the next one is heat activated batteries. These batteries are activated by supplying the heat only. Let us take that one of the battery which is having molten salt electrolyte. If we add the molten salt electrolyte, then the battery was activated. Let us take a solid salt electrolyte which is not activated. If you supply the heat, the salt gets converted into the molten condition. By supplying the heat energy, the salt electrolyte was converted into the molten condition state. Therefore, the conductivity is increased and becomes ionically conductive. Therefore, the cell was activated. By supplying the heat energy, the molten conditions was raised and becomes ionically conductive. The electrolyte was ionically conductive, thus it was activating the cell. These are also known as thermal batteries. Example, lithium and lithium alloys as anode batteries. With this, we have covered the reserve batteries are four types: water activated batteries, gas activated batteries, electrolyte activated batteries, and heat activated batteries. In today's class, we have discussed about the characteristics of a good battery. The first one is size and compact. A battery should have small size and compact and light in weight. Lightweight. It should have high capacity, ampere hour. It should have high energy density. Ampere hour per kg. It should be long lasting. The battery should be long last. It should have more number of cycles of charging and discharging, and should have more number of cycles of charging and discharging. It should undergo slow discharging and charging. The rate should be low. Slow discharging and charging. And the battery should have state of a health of a battery. The capacity was measured at different time intervals. Discharge of depth or depth of discharge. All these are the characteristics of a good battery. And the last word topic is classification of batteries. In this, we have studied one, primary battery, which is an irreversible battery. Primary battery, which is an irreversible battery which cannot be recharged. Example, dry cell lithium manganese dioxide battery. Second one is secondary battery, which is a reversible battery which can be recharged. Example, nickel cadmium battery, nickel metal hydride battery, and lithium ion battery. And third one is reserve batteries. With this, we have concluded today's class. In next class, we are going to discuss about the examples of primary batteries like dry cell or Lackland cell we used to call, or zinc air battery. Thank you.